Hi, my name is Henry Segerman. This is Fractal Graph 4. So this is another fractal graph produced by a process of iterated substitution. So this one is based on the cubic lattice. It starts with the vertices and edges of a cube, and then there are some substitution rules. So vertices of that graph are replaced by subgraphs, and then the edges are replaced by some number of parallel edges that connect those subgraphs together. And you follow those substitution rules and do them 4 times, and this is what you get. It's a sort of wonderfully craggy fractal object. So let me tell you what the substitution rules are. So we start with the vertices and edges of a cube, and then every vertex looks like this, where the 3 edges come out of the vertices, the vertex at right angles to each other. And that's replaced by this object here. So as with many of the other fractal graphs, so all of the vertices in this guy are degree 3, and so the vertex is replaced by this graph here with the green edges and the red vertices, and then where this vertex connects across to its neighbors over here, we have 3 edges replacing 1 edge here. Now you'll notice there's something a little different about this substitution rule, in that the replacement of the edge, these 3 edges are in a line, so you can sort of see the square face of this 3 by 3 by 3 cube, and these vertices, these edges connect out 3 edges in a line going down the middle of that square face. And so you have to worry, so if I've got this guy and there's some guy next to him over here, how do I know that these guys are going to line up? How do I know that they aren't sort of in the wrong orientation? And so there's a simple way to make sure that that's true. So I had an edge, well, previously, before I replaced this, I had this guy here, this edge connecting across in this direction, and I just make a rule: whenever I have an edge which is connecting across in this direction, the 3 replacement edges will be aligned in this orientation here, and with when I've got an edge coming out this way, the 3 guys come across in this direction, and up here they go across in here. So there's some sort of orientation issue you have to worry about. As long as you're consistent, then everything works out. So so we replace this guy with this guy, and then, as with Fractal Graph 3, now you have some vertices which have 3 guys coming out at right angles, and you also have some T-junction shape vertices, so you need some things to replace those kinds of vertices with. So here we are, this is the thing we need to replace, and there's actually 2 different cases to worry about. So depending on how things are arranged, so it could be that this guy here is arranged like this, and this is where the edges here, the 3 edges that replace it, are in this direction. And so you can either be pointing sort of along that direction, in which case you're in this case, or the 3rd edge out of the T can be pointing not in the direction of these 3 edges, but in the other direction. And in that case, you have this sort of replacement graph. So with these 2 different rules, you cover all of the possibilities. And now, together with the corner replacement, now we have a closed system. So now every kind of vertex in here is either 3 edges coming out at right angles or a T-junction, and we have these 2 different replacement graphs to deal with this, these 2 different cases of how the T is oriented relative to the directions of the 3 edges. And so you start with a cube, and you perform your substitution moves 4 times, and this is what you get. So this is Fractal Graph 4.